Hey, StrapiConf. My name is Jame Mackson. I'm the head of engineering at Upsie. We offer affordable warranties for your electronics with great customer service and quick claims. And we actually live that. Today, though, I want to talk to you about how we've refactored Upsie.com into a more performant, scalable, and SEO-friendly single-page app powered by Strapi and Ember. So today I want to run through the growing pains that we had with our existing architecture, talk about the priorities that we laid out for the refactor. I want to talk about the journey that we went through to integrate Strapi into this, and then wrap up with talking about the architecture and the impacts that all these efforts have made. So let's jump into the growing pains. So we had, here's a screenshot of the old version of our website. Our code base was typical of that of a startup. It's gone through a lot of twists and turns to find product market fit. This site was built up with statically implemented pages, which lent itself really well in the early days to experiment a lot on each different page, figure out what actually was going to resonate with customers, so we could find that product market fit. But as we got bigger and we scaled, needed to scale, site updates were slow for various different reasons, and we needed to reduce the friction for a product team to make updates to the site, ideally in a standardized way and without engineering's involvement. In that process, we had required PRs, and as such, it had to run our automated test suites and create builds, and then run through a Git flow release process. We host on Heroku, and so we had to do certain things to kind of make that fit into the flow. The deployment overhead, it just wasn't scaling well. Our product managers were resorting to submitting PRs of their own, not probably the best use of their time, and wasn't great from an engineering standpoint either. So we laid out some priorities. To take a quick step back, looking at the bigger picture, as a high-growth startup, our overarching charge is across the whole company to refine our craft and maximize our impact in all the efforts that we undertake. So this means supercharging marketing efforts to attract and win new customers, enabling customer service to best assist our customers and avoid creating them any undue work. And for the product team, we wanted to increase the experimentation velocity so that they could find the right messaging and the right content that was going to connect to users, to customers, and make sure that the whole process worked well. And we wanted to optimize our engineering efforts and make sure that our engineers are working on high value team, and we have good initiative velocity. So we wanted to tackle more new development and important initiatives. The place we really needed to start and where we got excited about Strapi, it was to really as a priority for our product team to remove those obstacles, to get content updates to be really fast, and allow engineering to really just get out of their way. We didn't want to code edit or do deployments. We wanted the time to complete updates to the site be measured in seconds, not minutes or hours, and without engineering assistance. So we also needed the site to be SEO friendly. As a marketing heavy organization currently, SEO is a big priority. The search engines all put value on site performance, but you also have to send the right signals and provide the right data for them to do their work. And these days that means rendering server side, so the search engines don't have to work. The harder you make them work, the less likely it is that they're going to complete indexing your site. So that means server rendered content, every piece of data in there, metadata, structured data, ideally without requiring running of your JS. And you need to send the right signals. 404 when the page isn't found, 301 when you are redirecting to a new site or a new page. So in site performance, like anyone, we wanted the site to be fast. It's important from a user experience, but also important for search engine rankings. So I found this quote: to gain several minutes of user attention, you must clearly communicate your value proposition within 10 seconds. And sometimes really even faster than that. So, and the site also needed to scale. As a growing startup, our typical call volume was increasing, and so we needed to be able to handle that. We also needed to handle large spikes. So for days like Black Friday and Cyber Monday, or an event sponsorship, or a new device drops that people want to cover, we need to be able to handle those and not worry about the site going down. So, and we needed to do all of these things without a big bang release. We needed to execute quickly, prioritize our work by impact, and release as often as we can to have those impactful initiatives see the light of day. Let's jump into the journey. So here's where we started. We historically had an Angular app, and that's where at the start of this, 99% of our content was still in Angular. We had the homepage in Ember. That was like our initial kind of experiment to see is this new framework, is this new architecture gonna deliver what we want? So we had a homepage in there. It was driven by static data fixtures, and we still have blog content in WordPress. So everything else was in Angular. So to avoid the big bang, we added Nginx as a reverse proxy in front of our web application servers. Those all connected to our API, which is a Node backend. We happen to use Koa and TypeORM, and those are backed by Redis and Postgres, and all of that runs in Heroku, with the exception of WordPress, which is still sitting in DigitalOcean. Everything is fronted by Cloudflare. So we started out with the proof of concept. We knew a CMS would be a game changer for content updates for the product team. One of our senior engineers had used Strapi before and really liked it, so we took it out for a spin and realized it really played well into our core competencies as a JavaScript house. We had experience with Koa, so we knew there was long term. I could see that there was some easy overlap. It wasn't a huge lift for our engineers to jump into the Strapi backend and do some customization, create middleware. And we actually have some opportunity to reuse some middleware and some things that we have in our core API. So we generated a new Strapi instance, which was a breeze. We created a page resource, super simple. And then we discovered the dynamic zone, and that's where things really got exciting for me. I knew this would open the doors for some dynamic rendering opportunities and allow us to really get a lot of bang for our buck in terms of the efforts we're going on. So we prototyped some dynamic page rendering, wrote some UI components to go along with that, and we're like, hey, we really got something here. So we had created a page resource. It looks largely like this. The primary components of it are the slug and the type. Slug obviously is where this page lives on our site, and the type largely describes what layout kind of controls the top level rendering. We've also decorated this object with some data for metadata, for JSON LD, some structured content on the site. And then we have our content property, and this is the Strapi dynamic zone, and this is really where the magic happens. So to go along with this, we needed a dynamic renderer. In the proof of concept, we built this fully dynamic renderer. Is really cool. We aliased the Strapi component name to had a way to translate that into a UI component that we'd then invoke fully dynamically. We just laid out kind of a call signature that was common across all these dynamic components. It was awesome, and Webpack hated it. So we use Ember. So Ember Embroider is the build pipeline that wraps around Webpack. And in order to do tree shaking and route splitting, it needed to statically analyze our code. And that fully dynamic implementation just did not work. So we had to go back and make a slightly less dynamic implementation, and Webpack was happy, and we could keep moving forward. So we did have to do some work to kind of time when we fetch data, so that we had all the data at the right time, and Ember would wait for that data to come in. We could render the site, get produced into the HTML, and and so that was. So we're at this point we're feeling good. We start to build out content. We're creating pages, building up our component library. Things are really starting to flow. So we had one-to-one Strapi components to our UI components. Things are flowing, and then somewhere, I don't know, around page 15 or so, things started to slow down. We noticed that the HTML payloads for the initial page requests were getting really big, and in turn slower. And even testing it with caching turned on, it didn't make the mark. So we knew we had some refactoring to do with this setup. At this point, up until this point, we were kind of blissfully, really naively, really requesting the whole world of pages from Strapi and deriving all the mechanics we needed to drive our dynamic renderer. But to keep performance up, we needed to still inform our dynamic router about what pages existed, what types of page they were, so it knew where to go and fetch them from. So we wanted to avoid the mechanics of this getting bogged down and having to ask the API if every single page requested. So we built a page index. So we ended up implementing this kind of in aside from Strapi itself. I probably could have implemented it in Strapi, but that felt like a big lift in that moment, and we just put it into our core API. But it's essentially a simple Pojo object that has like slug with like page type pairs, as you see in this example. And that informs our router about kind of what pages exist and allows us to quickly respond with the 404, for example, when a page doesn't exist. So we built an optimized page index. We had we had similar issues when we were building the product page that needed to know a lot of high-level details about what products, details of our product catalog. So those pages are even more data dependent than most. So, but we then refactored this process to intelligently look up what we knew about the page, and then refactored it to only look up, get the full page definition for the active initially requested page. So this minimized the data that we needed to put into the shoebox, was like the way we serialized data into the HTML, and then be able to rehydrate that on the back end, once that data comes back into our code. So. So we shoebox the data, and then we cache everything. Basically everything but your put, post, and patch requests you want to cache. And this was really starting to be a performant situation. So the next part of this is really stateless server-side rendering. To enable to be cacheable, you need what we render out of our server to be stateless, so that it applied to any user that would be requesting it. And it had to be structured in a way that at both our first paint is fast, but also the rehydration phase. With a single page app, you can have a very fast first paint, but if your rehydration is slow and or makes a bunch of like UI jank on the page, you're going to get penalized for that in your performance scores. So how we get the data for the dynamic data and then render that content out is really important. So we pre-render the HTML out of our server. That gets the initial page load fast. We get server side, we get all our API and third-party data that we need to drive this. And then we embed that data into the HTML so that it's there client side, so that when that rehydration phase that happens, it doesn't feel like it needs to go out and get that data again, so that it has it to be able to re-render the page. And it's really important that we do this so that no client-side API calls are needed for the rehydration of that first page. Once you start navigating inside the app, it just behaves like a typical single-page app, and makes API calls that it needs for subsequent page requests. So the embedding of this data into the indoor HTML. So we use Ember. Ember's server-side rendering library is called Fastboot. And one feature within Fastboot is this shoebox. And this is a means for us to serialize data into the HTML that then lives in the DOM and is available client-side without doing any asynchronous work. So it when realized, it looks like a series of scripts like this that exist in the HTML. Works super slick. So, and then the last thing with this is turning on Cloudflare caching, or choose your cache. As long as you can point everything to that, and it'll pass through your post, put, and patch requests. It really should work for this architecture. We've been able to cache roughly 80% of all of the traffic that comes to Upsie.com. Both front end and back end requests. And you can see in this diagram, the green represents the total requests that come to our domain. And the little slivers of pink at the bottom, that is the portion of those that make it through to our origins. So, and then in Cloudflare, it's a simple page rule that turns on this level of caching, and we set what TTL we want for the browser and both and on the edge of their CDN network. So let's talk a little bit about how the architecture evolved. We put Strapi in place. We turned our API repository into a monorepo. So both our core API and Strapi coexist side by side. They share a Postgres server where our core API uses the public schema, Strapi uses a content schema, so they can live in safe harmony in parallel to each other. We put Nginx in front of those so that we can handle routing within our dynos to the right resource. We expose Strapi through a separate domain so that all those requests can make their way over to Strapi safely. And then we, in the process of moving our content into Strapi, we phased out the Angular application on our front end. So we still have Nginx sitting in front, but that may get phased out. And eventually we'll move our WordPress stuff into Strapi most likely, but today WordPress still exists. So the impacts that this had. So we moved probably 95% of our non-blog pages have been moved over to Strapi. We've reduced the time to publish the most simple content by probably 99%. It went from roughly an hour to maybe 30 seconds. And the cumulative efforts of all of these things, not simply implementing Strapi, but kind of all the things that were happening in the process of doing this, a year-over-year conversion rate has gone up 27%, which is pretty good. So, and really all of this, it starts with having a good product. Our engineering team has created a space for a product team to really go do their work and enable them to increase their experimentation velocity, which leads to better content on the site, which connects then with prospective customers and translates to sales. So as long as we deliver on what we advertise, we have happy customers, and that's really what this is all about. So on-page performance, that's obviously a big part of this, and our baseline performance went up roughly 60 points. Lighthouse is kind of a moving target, but on average, we're about 60 points better than we were when we started. And when I say baseline performance, that's measuring what our native web applications performance is, really like straight out of our code and without any third-party libraries. So we're a heavy marketing organization, and there's a lot of third-party tools that enable an informed marketing effort, and to be so that effort is really measured and effective. So we put in systems in place to both measure our baseline performance and then performance with all the third-party stuff turned on, so we can actually measure the relative cost of all of these different tools. It's always a trade-off, and we need to be an effective organization, we have to carefully consider the return on the investments that we make, both in actual money, but both as well as performance costs on the site. So I think we've really landed on a happy medium. Our Lighthouse scores are not they're not A pluses, but we've really focused on making a big impact and having a great user experience. And I think we've made really marked improvements in both of those things with the results of these efforts. So, in closing, I think the key takeaways from this are really the Strapi dynamic zones are a crazy powerful construct. It really opens some doors for higher order approach to how you render your content. We found that the timing of how you get your data really matters. Getting the data server side is great to render, but you can't have your front end then going and getting that data again to do the rehydration phase. So like embedding that data into your HTML is key, and then cache everything. It's critically important, and I think that's what makes this architecture rival Jamstack, but not require CI builds to accomplish. Simple clearing of cache, and things are and your changes are out in the world, and you don't have to wait for a rebuild. So that's really my talk. I look forward to seeing your comments in the chat, and thank you for coming to StrapiConf. And hey, we're hiring, so feel free to reach out if you're interested. Thank you so much.